Alrighty, double session today. Alright, let's also have a look at 9F, which is differentiation rational powers. Again, generally speaking, there shouldn't be any surprises here. It's just done the same way as other differentiation. However, there is a little bit of background information that they want you to go into, and we do need to have a bit of a chat about this stuff so that you do have an understanding of at least some of the questions that they can ask you. So it says here, before using the chain rule to differentiate rational powers, we're going to show you how to differentiate x to the power of a half and x to the power of a cube. X to the power of a cube, x to the power of 1/3 by first principles. Let's have a look here, first of all, at x to the power of a half, where x is a value greater than 0. So first principles, writing it out. Please remember that x to the power of a half is the same as the square root of x. Yep. So again, what you're going to have is the square root of x plus h, take away the square root of x over h. We're going to basically get rid of these square root signs on the top line by rationalizing the denominator. So we need to multiply it by 1 essentially to get rid of these square root signs. By doing that, you can see we get rid of these square root signs on the top line, but along the bottom line it gets multiplied by obviously that there. From here, things can simplify down. Obviously if we've got h and we've got a h here, they cancel each other out. Fits into itself once, so fits into itself once. X take away x is 0, so you're just left with the 1 on the top line there. Okay, so hopefully you can see how that works. And again, just so we're cool, when we simplify it down here, you've got 1 over the square root of x plus h plus the square root of x. When as the limit as h approaches 0, that effectively disappears, and you're left with the square root of x plus the square root of x on the bottom line, which is the same as 2 lots of square root x. Yep. This one here is requiring a bit of background knowledge. Just try and work through this here. So what they're saying is, consider from previously, we know that the identity a cubed take away b cubed is the same as this here. And they're saying, hey, also remember, if you've got a to the power of a third and that is to the power of 3, that just becomes a. Yep, and likewise here. So to get rid of these cubes, what you can essentially do is raise these to a third. Yep. So again, that's why this here is to a third, this here is to a third. Here, each of these is divided by 3, also to the power of 3. This is to a third, this is to a third, and this is obviously divided by 3 as well, 2/3. Yep. It's applying that rule there. Yep. What they're saying as well is that can be rearranged and you get this here. Cool. So hold on to that thought there for the moment. Again, using first principles, we've got the functions here, which was g of x. Rewriting it out, it's going to be this one here to a third, take away x to the power of a third. So we've done that. Again, applying the same process as we did in the previous question to simplify things down. We know that this simplification takes on this sort of process here, yep, which is what they've done to simplify it down. Spend some time having a little bit of a think about it. It's similar to above, yep, but it's basically applying this rule to simplify it down here. Again, the h's cancel out to 1, so 1's on the top line, x take away x is 0, we've got rid of that. Cool, so that's first principles, which can take a little bit of time for you to understand. Now ultimately again here, for this process, you need to know that where you've got y equals x to the power of 1 over n, again, same difference. That just, when you're finding the derivative, that comes down in front, so it gets multiplied by 1 over n, and then you take away 1 from that power. Okay, it looks more complicated than it actually is. Yep. So when we actually do this here, again, this negative 1/5 gets multiplied by 2. Then we take away 1 from that power, which comes to here. Likewise, 2/7 multiplied by 3 gives us that. Take away 1 from the power, we end up with that. Yep. Over here, we've got the cube root of x squared plus 2x. Remember, instead of writing the cube root, it could be the same as this here to the power of a third. Once you've established that that's the same as this to the power of a third, you can apply the chain rule like we were doing in the previous exercise. Yep. So remember, u is obviously going to be x squared plus 2x. You'll need to find the derivative of that. Then you're going to be left with y equals u to the power of a third. You need to apply the rules that we had before for dy dx is equal to dy du multiplied by du dx. Writing it out, which is the chain rule, and then obviously writing things out using positive powers. Cool. Another little snapshot there. You guys should be right to have a go at this one now. 9F. 2 exercises in one day. Cool. Exciting times. Bye for now again.